Welcome back, as opposed to get lost like many of you grade 9s are joking about. So welcome back. So I just finished doing this question where there are 6 zeros, so it's 0.000000025 ppm. Again, if we convert this into a milligram per kilogram, a milligram over 1 kilogram is equivalent to a part per million. Let's keep going. Next, it just wants you to explain what toxicity is and acute toxicity versus chronic. So in general, toxicity is the ability of a chemical to cause harm, and if it's acute, that means that symptoms are going to occur right away, whereas if it's chronic, symptoms will appear after a little while, and it could take some time. Next, LD50. So LD50, which is on page 218. Okay, what does it stand for? The chemical that kills 50% of the population to which it is applied. They often will test rats to get the LD50. Of course, you can't test humans. It's also sort of almost unethical to do it on rats, but that's how they come up with the LD50s. So the higher the LD50, LD50, the more toxic the substance. Sorry, let's talk about that again, not the higher, the lower. So, for example, something like dioxin is an LD50 of 0.03 parts per million. That means that that amount, that low concentration, will kill 50% of the population. Well, what if something has an LD50 of 80.0 parts per million? Which one is more lethal? This one, because look at how much smaller it can be to kill 50%. You need a lot more of this chemical to kill 50% of the population. You only need a tiny bit of this. So the LD50, the smaller the LD50, the more lethal it is, because you only need a little dose of it. What is the most lethal? Botulinum, which comes from botulism, and it's a bacteria. Its LD50 is tiny. I think it's like 7 zeros, 2, 3, 4, 5, 6, 7, 3 parts per million. That's all you need, that teeny tiny bit to kill 50% of the population. So a really lethal substance. 3 reasons it is difficult to establish risk for chemicals. 1, a dose that kills 1 person may cause only mild discomfort, so we all have sort of different tolerance levels. 2, the toxicity often depends on how the chemical gets into your body. Okay, it could actually be diffused by something. It could be blocked by your body. Few actual measurements are made on humans. Don't forget, for example, it's unethical to test on humans, and LD50s are usually based on rats. Saccharin is a sugar substitute that's known to cause cancerous effects to some lab animals. Why is it still used in our food products? Something called acceptable risk. Saccharin generates an almost undetectable risk of cancer in humans, and so they decided not to worry about it. So again, acceptable risk on page 219, you can see more about how acceptable risk works for other substances as well. There's the issue of thalidomide, which was given to pregnant mothers, and what happened was it caused birth defects. And so why did they end up giving it? To help nausea and so on, and to help pregnant mothers sleep better when it caused birth defects. They did